Another thing I didn't think about changing was like maybe the gate timing. So locks on pretty quick. It indicates 0.01. And that says 0.1. Gives us a little more resolution. .1.0. Okay, I don't know what that really means. And it's taken a while to read. 146520301. And it'll change, but it'll be like a lot more stable. Okay, that's 1.0. We have 10. I'd imagine that's really going to take a while to read. Let's see. Wait. That's ridiculous. Okay. So, real long time to lock. Wait, key. How long does it stay for? A little while. So, that gate right there is very slow. It's 10. I don't think it goes higher. Let me just go really fast, which will immediately lock on. I would say that this is probably going to be better than most of like what I'm going to buy. I remember they were selling these years ago with a different label on it, and they were like 150 bucks. So now let's go ahead and try like this one. So this one has a counter in it too. It's like super old. This is the old 259. The B was a better one. So on this one here, we have a counter input, and I'm pretty sure that we have to use it. Let's go ahead and hook this up now. So we would check the input and the gate right here. So I think right now we're just set up to read frequency. And see, it doesn't read the same as the other one. If you're doing an alignment on the radio, that would kind of be a problem, because it's off by a bit. When we change the gate here, 51982. So this appears to be very similar to this display. Let's go a little further on the gate. Again, the accuracy doesn't really change. Oh, it goes even further. I wonder how many times it'll do this. This is probably the equivalent of the last one where it took like a really long time to lock. So it's reading 102. I'm kind of close by. I don't think I should have to do anything with it. There we go. That took a long time. So very slow to react to change. Slow to get a reading and slow to drop down to nothing. Okay, let's push this gate one more time. Okay, so that's our fast gate. So let's see here. So has to be pretty close. So see how it does that. Like, so I'm like really close to it, and it's not working. Okay, so you need something, an antenna maybe, or even a probe. I don't know. I guess maybe you could do repairs on the radio. My friend Kevin was telling me about what's called an active probe. I think that's probably what would, work. He was also talking about an interesting way to do that too, using a radio like a 7300 and just look at the center frequency. Okay, so this thing, I'm not sure that it works. We have a 1 mega ohm input and a 50 ohm. That goes up to 250 megahertz. This goes to 110. And this is a 250 megahertz counter. They have all these different things here. Okay. OPCL, period average. Variable display, power off, hold. So I think this is basically the gate. Okay. And then you have attenuation. And then you have a knob here. And as I recall, it's just a knob, not two knobs. So the milliseconds, microseconds. So you have your time base, which I guess has nothing to do with... So this is in the Hertz domain. So we would not be looking at Hertz, we would be looking at megahertz. I'm just curious if I bring this near it. So it doesn't seem to do anything doing that. Alright, let's try this. We get nothing. Okay, so when I get near it, yeah, it looks like it works. Okay. You know, there might not be anything wrong with this damn thing. Now, I'm wondering what happens if I do 100 on attenuation. It still pulls it in. Okay, so that's going to be megahertz right here. So, a little coarser, I guess. What does it read? Let me see. How many digits does it give me? So it gives me 3 digits after my megahertz. Okay, this one here. I wonder. So this is going to be our maximum. But you see, it doesn't really want to lock on. 5201. How many digits is that? You get megahertz. You see it's very unstable. 520. Yeah, so down to the hertz. They go kilohertz. It will show us the tail end of it, I think, maybe. Oh, I didn't know it would do that. There's another digit right there. 1465210. Cool. Kind of goofy. So we have a 1.465. So this is going to give you the most resolution. I don't believe it can go further than that. And these, we'll just leave that in there. That should be fun. Anyway, so microseconds, milliseconds. Okay, so faster, slower. Okay, let's see what we get. Oh, and this is going to take like a really, really long time to read. Yeah, see, look at that. So, to me, it looks like this thing does work. Also, it should be noted, I have this on the wrong connector completely. Input is over here. I'm going to turn the attenuator on. I'm going to go back up to here. See what it does. Pulled it right up. Okay, so being on the correct port makes a big difference. Seems to be a lot more sensitive. I'll be damned, this thing might actually work right. So for my kind of testing, what would I be looking at? I'd be looking at, like, I think the last one I was looking at was 36 megahertz. And I needed, you know, a resolution to be more than that. This really does seem to behave perfectly fine under these type of applications. But what I found with all of these is that when I went to go into a radio and use them as a frequency counter to measure a test point, it just wouldn't read anything. None of them. Yeah, none of them would. So I don't know what the reason is why. I was using oscilloscope probes. I had them on 1x. I didn't have them on 10x. Let's try this real quick. 146520 with 2 more digits, which is weird because, okay, 146520 with 1 more digit. Okay, so this is gonna cut off the 1. 14652097, and this I think has a oven in it, but I can't remember. So why am I thinking this thing is like completely broken? I guess because I probably wasn't using it properly. I just don't think that they're capable or sensitive enough, or somebody blew out the front end of it. This is what somebody else told me, that it might have got too close to a signal. Anyway, I'm sure there's a bunch of guys on my channel that know a lot more than I do about this kind of stuff. So maybe you can chime in and let me know, is this normal, or is my equipment broken, or my expectations broken? Let me know.